All right, hello everybody. Just wanted to go over the Unit 6 review. I know that we didn't have time to go over all these questions in class and I didn't get to everybody. So please follow along as I go through the review and I'll try my best to give good explanations as I'm going. All right, so with number one, again, this is an algebraic proof. We have our given statement of 4x minus 10 equals 2x, which is what we start with. So we're going to go ahead and drag that given up there. We also then see from 4x minus 10 equals 2x, we get to 2x minus 10 equals 0. Looks like that 2x went away on the right side. And if I look over here, I went from 4x to 2x. Looks like 2x went away there too as well. I subtracted 2x from both sides. So that's going to be the subtraction property of equality. We then, all of a sudden, we go from 0 to 10 on the right, and that minus 10 went away on the left side. So we added 10 to both sides. So that's the addition property of equality. And lastly, we went from 2x equals 10 to x equals 5. Well, just think about what step you would do to solve this equation. You'd divide both sides by 2, which is what we did. We divided both sides by 2. So that's the division property of equality. All right. That takes care of the first one. All right, if we go to number 2, well, let me check it just to make sure. We go to number 2, another algebraic proof. Looks like that minus, well, we have a given statement to start. Okay. Looks like we added 4 from the first step to the second step, added 4 to both sides. That's the addition property of equality. From 5x equals 25 to x equals 5, we divided both sides by 5, division property of equality. And then we went from x equals 5 to 5 equals x. We are allowed to switch both sides of the equation using the symmetric property, right? The symmetric property. Okay, there's our 4 for number 2. Number 3, and as I'm going through this, please feel free to pause the video, go back in the video, whatever you need to do, it'll help you out. All right, we were given that AB equals CD, or not equals, AB is parallel to CD, and AE is congruent to DE. All right. We're trying to prove the two triangles are congruent. All right. Now, I'm going to go ahead and mark a couple things here. We're told that these are parallel and, and AE is congruent. All right. It's congruent to ED, which is marked for us. Okay. We don't know that AB is congruent to CD. But when we have parallel lines, I know that we're going to have alternate interior angles that are congruent, okay? And I think that's going to be one of our first steps in our proof. All right, so again, we have these parallel sides, A, B, and C, D, because that's what we are given, all right? And we're also given that AE is congruent to ED. All right, let's go back down here. Let me get off my pen. There we go. All right. We have our given statement to start. All right, we're also told blank and vertical angles. Well, we have a pair of vertical angles. I forgot to mark that on there. These angles are congruent. They're the vertical angle pair. All right, all vertical angles are congruent. So if we identify these two angles as congruent, we can always use that reason of vertical angles being congruent. Okay. Oh, they stay there. That's awesome. All right, vertical angles are congruent. Well, those vertical angles were AEB and CED. Well, E. Oh, I gotta go down here. AEB and DEC. There we go. There's our vertical angles. All right. Angle BAE and CDE. BAE and CDE. That is that pair that we had talked about being congruent because of alternate interior angles. Okay, alternate interior angles. So look down here, there's an alternate interior angle reason. We now have enough information to say the triangles are congruent because of angle, side, angle. Now I have to look in both triangles to make sure that fits, but angle, side, angle. Yep, that does work. Angle, side, angle goes there for step D. Okay. Give a quick check. There we go. Question 4. All right. So we got our, let's mark what we got here to start off. And should have said this at the beginning. With all of our triangle proofs, I recommend you either have scratch paper or a whiteboard or a marker that you can write on your desk. You should be marking these things off as you're going. They're really going to help you out within your proof. So we're told that AD is congruent to CD. So those two are congruent. We're told that B is the midpoint of AC. Now, that's not marked on here, but we know that if B is the midpoint, the two small segments on either side of that midpoint are going to be congruent. All right. I also can look on here and see that we do have a shared side. All right, which is the DB. I can look at what we marked here and what we know from our given information. We're going to use side, side, side to prove these two triangles are congruent. All right, but let's work through the proof and see how we get from the beginning to the end here. We have our given information, which is first. We're then told that AB is congruent to CB, AB and CB. Remember, we know those are congruent because B is the midpoint. All right, so we're going to use the definition of midpoint to prove those two segments are congruent. The reason for step C is reflexive. Well, that was because DB is congruent to itself. Might be BD on here. There we go. And now between the first three steps, we have one side pair, two side pairs, three side pairs. Side, side, side is going to be our reason for proving the triangles are congruent. Triangle ABD is congruent to triangle CBD. Okay, there we go. Number 5. All right, and one other thing about the test you're going to be taking, make sure that with every proof, you do your best, and I would, at the very least, mark down all the parts that you know are correct, like especially given parts or maybe the finishing statements or parts, because you get partial credit for everything you get right. But it also doesn't hurt if you have a couple on here that like, I'm not really sure what they are. Just do your best and maybe just give it a guess, because you never know, you might get it right, but you're going to get partial credit for each of these questions that you get correct. All right, each of the reasons or statements you get correct. So don't just leave the whole thing blank because you don't know how to do the whole thing. Mark the parts that you know. All right, so starting at the beginning, I'm going to go ahead and mark down the parts are given. It says BD is perpendicular to AC. Well, if these two things are perpendicular, I know that because of definition of perpendicular, we're going to get some right angles, and right angles are going to be congruent. We're also told that angle A is congruent to angle C. All right, let's go down and see how the proof's going to go about moving through here. Let's see. We have our given statement first, so we're going to go ahead and put given in there for first, the first thing. Okay. We're also says, the next blank says sides opposite congruent angles in a triangle are congruent. This goes back to one of our earlier units. If we have congruent angles and we're looking at this big ABC triangle, okay? If we have two congruent angles, remember that if angles are congruent, the sides opposite those angles are also going to be congruent, all right? So we just proved that those two sides are congruent because these two angles are congruent, all right? And that's essentially the fact that we're going to use here in step B. Because those angles are congruent, we know that AB and CB are going to be congruent sides. So AB and BC, those are congruent sides. All right. Step C, BD is congruent to BD. Well, that's the shared side, which is always proven. The reason why is by the reflexive property. Angle BDA and angle BDC are right angles. All right. This doesn't say they're congruent. It just says they're right angles. We know they're right angles because of definition of perpendicular. Okay. If you have perpendicular lines, it makes right angles. Once we've proven they're right angles, we can say that those two angles are congruent. All right, so angle BDA is congruent to angle BDC. All right, and the reason why we know they're congruent is because we know they're the same angle measure. They're both right angles, which are 90 degrees. So because they're congruent because of the definition of congruent angles. All right, we now, looking up at our diagram, okay, we had also talked about the reflexive side. So it looks to me like we have two angles and two sides. All right, two angles and two sides. So there's actually two ways we could prove that these are congruent. We could use angle, angle, side, or because we proved that AB and CB are congruent, we could use hypotenuse leg. All right, so let's look back down on our proof, or in our choices here, angle, angle, side, or hypotenuse leg. Now there is no angle, angle, side option, but there is a hypotenuse leg option. Okay, so we're going to use that one. All right. And that does give us the correct answers. Number 6. All right. We've got angle A is congruent to angle C, which is marked. Angle ADB is congruent to angle CBD, that is marked. And we're trying to prove that angle ABD is congruent to angle CDB. So we're trying to prove that these two angles are congruent. Okay? So A is our given statement. So our given statement was angle A is angle C, congruent to angle C. Let's go ahead and find that and drag and drop that up there. There it is. There's the given information. Step B is the reflexive property. So that's going to be our shared side. BD is congruent to BD. Now we have enough information to prove the triangles are congruent. Not worrying about our dotted angles there, which that's the last step. But we have two angles and a side. Okay, because we just talked about our shared side. So that is angle, angle, side. The side is not between the angles, so it's going to be angle, angle, side for step C. There's angle, angle, side. Now, if you ever are trying to prove that like angles or sides are congruent, there's a very good chance that you're going to be using CPCTC. Just to double check, we've now proven the two triangles are congruent in step C. Well, we just proved that all three corresponding sides are congruent. Okay. And all three angles. All right. So we now know that that angle pair that we were looking for at the beginning are congruent, and they're congruent because of CPCTC. Okay. All right. Number 7. All right. We know that angle 1 is congruent to angle 2, and AB is congruent to AD. I'm going to go ahead and mark them on there. Angle 1 is congruent to angle 2, and AB is congruent to AD. All right. That's our given information. I do see our reflexive side. I think that gives us enough information to prove the triangles are congruent. Side, angle, side. All right, let's go down here. We got our given step first. AC congruent to AC, that's reflexive. Triangle BCA, we just talked about, that's going to be side, angle, side. Once we prove the triangles are congruent, you know all the parts are congruent, okay? All the corresponding parts are congruent. Those all three sides. We got, sorry, this is a little sloppy. You know those angles, B and D are congruent, and also our third pair over here are congruent. Okay, so angle BCA, well, that was that third pair I did, angle 3, and this is angle 3 and angle 4. These two angles are going to be congruent because of CPCTC. All right, number 8. All right, now this one kind of goes, this is the beyond CPCTC part, because now our last step isn't trying to prove that like two sides are congruent or two angles are congruent. We're trying to prove something else. So we're going to have to prove using CPCTC along the way, but then there's another step at the end. So let's mark what we know for this one. We know AD is parallel to BC, and AD is congruent to BC. Right? I also see a vertical angle here. I also see, because of the parallel lines, we've got some alternate interior angles that are going to be congruent. All right. And your next two steps after the given part is where we're going to use alternate interior angles are congruent. All right. So we got our given information first. These next two steps are the double marked angles here and the triple marked angles here being congruent. All right. We're going to use the same reason for both. Alternate interior angles congruent, alternate interior angles congruent. We have enough information now, right? To be honest, we didn't say anything about vertical angles, so we can't even use the ones that I have marked on here. We can only use the double and triple that are on the ends, but that's going to be angle, side, angle, angle, side, angle. All right, angle, side, angle. Now, because we proved the two triangles are congruent, we know that all the sides are. So the AE congruent to EC part, which is the next step, is going to be true. Okay, we know that these two sides are congruent, and that is CPCTC. And why did we pick that one? We could have talked about the other ones. We could have said DE is congruent to BE. That's not going to help us, though. All right. We're trying to prove that E is the midpoint of AC. So in order to prove that E is the midpoint of AC, we need to prove that AE is the same length as EC. All right. So E is the midpoint of AC. That is true because of the definition of midpoint. Because we had two congruent segments, all right, that were part of a big segment, which means that the point in between them is the midpoint. In this case, E. All right, there we go. Number 9. Identify which of the following definitions in our pictures display or represent a bisector. Well, a bisector is anything that divides a bigger thing into two equal parts. All right, so a line that intersects with a segment, not enough info. This picture, those don't look like equal segments. A line that intersects a segment at its midpoint. That'll work because the midpoints are exactly in the middle of a segment. A line that cuts a segment into two congruent parts. That works. This diagram up here is going to be good because the ray OC is cutting angle AOB into two smaller but congruent angles. A ray that forms two congruent angles. That works. That's exactly what OC is doing. A ray that splits an angle into two equal parts. Yes. A line that bisects the segment. Yes, that works. This picture up here is also going to work because line CD cuts segment AB exactly in half. You can see because of those single hashes there. A ray that intersects with the vertex of an angle. Just intersecting is not enough. It's got to cut it exactly in half. And the bottom one, 20 and 80 aren't equal. So that red ray does not work. So this is quite a few answers, but all of these are true. Okay. Number 10. Identify which of the following definitions and or pictures display or represent congruent alternate interior angles. Congruent. Well, they're only going to be congruent if there's parallel lines. Okay. So there are alternate interior angles in this first one, but they're not parallel lines, therefore not congruent. A pair of angles formed by the intersection of two lines. Nope, that's just, again, could be corresponding angles, could be alternate exterior. It's not specific enough. This third one works. These purple angles that are marked are alternate interior, and we have parallel sides there on the ends. A pair of angles that are both exterior. Nope. If we knew that ED and BC were parallel, it would work here for this green one in the middle, but it doesn't. A pair of angles add up to 180. Nope, that won't work. Close here in the bottom top right, those are alternate exterior. A pair of angles that are both interior and opposite side of the transversal. Those are alternate interior angles, but they are not, it doesn't say they're congruent, all right? But this last one on the bottom right, that one does work. Those are alternate interior and they're congruent. Okay. All right, let me see. Are there any other questions that I'm missing here? Yeah, there are. Number 11, identify which of the following images contain vertical angle pairs. All right, no vertical angles in the first one, the middle and the bottom, but it looks like we got vertical angles in this bottom left, top right, and bottom right. There's an intersection, and at the intersection is where you'll find vertical angles. Okay, so that should be correct for number 11. And lastly, number 12. Identify which of the following images contain a regular polygon. Regular polygons have two facts. All sides are the same length, and all angles are the same measure. A has all the angles the same measure, but sides aren't the same length. B, the sides are the same length, but the angles aren't the same measure. C, angles are the same, but sides are not. D, all three sides are the same, all three angles are the same. That is a regular polygon. Okay. Hopefully going through this helps you guys out. Feel free to take a look at this either Monday afternoon, night, or Tuesday morning before you take your test on Tuesday. Again, pause things if you need to. My last recommendation, make sure that you are copying things down, especially with your triangle proofs, and marking the parts down so you can visually see them rather than just looking at a blank image on the Edge Elastic test. All right. Good luck tomorrow.